Hi friends, welcome back. Today we are going to solve one hard Leetcode coding interview problem. It's 773 sliding puzzle. So as you can see here from like dislike ratio, this is another quite likable and popular Leetcode coding interview problem. This is a hard coding question. So we are going to understand this problem with some examples, and we are also going to understand the logic as well as the Java solution code to solve this coding problem. If you are new to this channel, please subscribe to this channel now. Also click on the bell notification icon button right away so you won't miss any important postings from this channel. Here we create videos and content to help others in their interview preparation and learning different computer science concepts along with data structures, algorithms, problem solving, logic building, programming and coding. So let's start. On an 2 by 3 board, there are 5 tiles labeled from 1 to 5 and an empty square represented by 0. A move consists of choosing 0 and a 4 directionally adjacent number and swapping it. The state of the board is solved if and only if the board becomes 1, 2, 3 and 4, 5, 0. Given the puzzle board, return the least number of moves required so that the state of the board is solved. If it is impossible for the state of the board to be solved, then return -1. So this is what the problem statement says. So we'll go through the examples. Constraint says that the board dot length is equal to 2, board I dot length is equal to 3. So it's a fixed size matrix basically, and 0 is less than equal to board ij is less than equal to 5. So it will only contain 0, 1, 2, 3, 4, 5. Each value board ij is unique. Okay, so this is what the problem says. So let's understand what the problem is with some examples. So this is the first example, as you can see here on the screen. So here this is the current state of the board. So 1, 2, 3 and 4, 0, 5. So this empty means it's a 0 basically, right? So let's take a look at what is the solved state. So solved state is 1, 2, 3, 4, 5, 0, right? So let's take a look here. So 1, 2, 3 and 450 is the solved state, right? 450. So this is where we want to reach basically, correct? So right now 1 to 3 is 1 to 3 matching. The problem is with this 0 should go here basically, right? So 0 should go here, correct? And 5 should go here. So in one swap we can do that, right? So 5 you can bring here and 0 you can put here in one swap, because you are allowed to do the operation, right? Because this is 4 directionally connected to 0, correct? 0 and 5 are 4 directionally connected, correct? So 4 directions are horizontal and vertical. So this move is possible. So you will bring 5 here, put 0 here. So in one move you can actually solve the problem, right? That is the minimum number of move you will need to solve this problem. So that's what we want to find out. There is a bigger example over here. So 412, so let's write down that here. So this is a bigger example here. So 412, right? 412 and 503 is your current state, right? 503 is your current state. So here now we want to they are explaining here what will be the moves, right? So 412 you will remain as it is 053. So 0 will go here and 5 will come here, right? So basically you put 0 here and you put 5 here, right? Okay, so this is a one move. Okay, this is the one move. Now in the second move what you will do is you will swap this 4 and 0, right? These two. So you will swap it. So what will happen? 4 will come here, right? And 0 will go here, right? Okay, so this is two moves are done now, right? In the third move you will swap 1 and 0, right? So 0 will come here and 1 will go here, correct? This is the third move. In the fourth move, right, in the fourth move you will swap 0 and 2, right? So this will become 0 and this will become 2, correct? So this became 2, this became 0. And in the fifth move, right, fifth move you have to do 1 2 3. So now these two you have to swap, right? So this one will become 3 and this one will become 0, correct? And this is your state where the matrix is solved, right? So 1 2 3 4 5 0 is what you want to reach, right? 1 2 3 4 5 0 is your state where you want to reach basically. So now you reach that step, right? 1 2 3 4 5 0. It took you 5 steps to reach there. This is the minimum number of steps in this case to reach to the target state. So that's what we want to find out. So you understood this problem clearly and you understood how the moves are made, right? So you have to make the moves with 0, right? So 0, and you can go in 4 directions. So you can make move here or here or here, right? With 0, 4 directions, right? So one possible move is you can put 5 here and you can put 0 here. That is a one possible move, right? Other possible move is you can put 3 here, you can put 0 here. This is another possible move. Other possible move is you can put 1 here and you can put 0 here, right? This is another possible move. So we need to find out the minimum number of moves, right? Smallest number of moves. This is very important, right? So now you understood this problem. If one other thing is, if the it's not possible to reach this target state, in that case you will return -1, right? So this is what the problem says. So now you understood the problem, what that sliding puzzle problem is asking us to do. So we want to find out minimum steps. So how can we solve this problem? So we can use a very important coding technique called as DFS here, right? Depth first search or depth first traversal. So it means that we have to first find out where this 0 is located, right? So we have to first find out this cell where the 0 is located, right? Once you find out this cell, then you will start going in 4 directions, right? You will start going in 4 possible directions, and you will start expanding it, and you will start swapping the, you will use the move basically, where swapping, right? Swapping is your move. So you will keep moving, doing those swapping moves, and you will also have to keep track of the state of your matrix, right? So we can do the hashing for that, so that we can take this whole matrix and we can do the hash on this matrix, right? So that we can actually store the state of that matrix, so that we will know how many steps we actually needed to reach to that state of the matrix, right? So I'll show you how to do that hash. So once you reach this target state, right, this target state, you will keep track of the minimum moves it needed to reach there, right? Minimum moves. So we'll keep track of that actually, because you can reach this target state by other moves also, right? So this is one move which is minimum, but it is possible that you can do more than one move and still reach this state, right? So we are only interested in minimum number of moves. So that's why we will keep track of the minimum number of moves as well, right? So at the end we will have to just return that minimum number of moves, right? So this is how we can solve this problem. So when you are going in 4 directions, right? So let's understand these 4 directions for the people who are new to development, who doesn't know that. So I'll quickly explain what that means, so that they will know. So if you are currently at this cell ij, right, then these are the 4 possible directions for you, right? I minus 1j, I plus 1j, right? So this is another cell which is adjacent. This cell is I j plus 1, correct? And this cell is I j minus 1, right? So these are the 4 adjacent cell for this cell, correct? So these are horizontal and vertically adjacent cells, which are also known as up, down, right and left basically, correct? So these directions also we will create, so that we can actually go in 4 directions and do the swapping moves. So let's take a look at the DFS code. So we'll use recursion there. We'll also keep saving the state of the matrix, so that we can store it, right? Because we don't want to again recalculate that state. So we'll know already how many moves it took us to reach to that state, right? So I'll show you the code now step by step so you understand how to solve that sliding puzzle coding problem. So here a couple of variables we'll create first. So we'll create one map which is a string comma integer, right? So it will hold you the state of that matrix, and it will hold the integer is the number of moves to reach to that step, right? After that, these are the four directions that I just shown you. I shown you these four directions, right? So these four directions are here in this directions array, which is a 2D integer array. After that, we'll create two variables, answer and infinity. Both will be assigned to the integer dot max value in the beginning, right? After that, we'll create, this is our main method sliding puzzle, and 2D integer array, which is a board, is given to us as input. We are going to return int, which is minimum number of moves required to reach to the target state, right? So we'll first create two variables, x and y are 0. We will, in these two nested for loops, we are going through the board and we are identifying the location of the cell where 0 is, right? So first we want to find out where this 0 is located here, right, in that matrix. So that's what we are doing here. Once you find that cell, you will just say x is equal to I, y is equal to j, and then you will break out of these loops, right? Okay, so you now know the location of that 0. So you will start applying DFS on it now. So this is the DFS call, which you input the board here. You input the location of 0, which is xy cell, and you input the 0, which is number of steps in the beginning. They are 0, right? So this is our public void DFS method, right? Before I show you the DFS method, I will show you some other methods first. So there is a method here called as isSolved. So isSolved method actually returns us true if the board matrix is the target state. So this is the target state. I shown you this is the target state, right? This is the target state. So this target state we will check in this method, right? So 0 0 should be 1, 0 1 should be 2, 0 2 should be 3, 1 0 should be 4, 1 1 should be 5, 1 2 should be 0. So this is a isSolved method. So this one will return true if your board reaches the target state. So this is another important method that I was talking about, where we will create a hash for the matrix, right? So we'll just use a string builder here to build the hash basically. So hash will build a string basically for that matrix, right? So here we are going to go through the matrix, and we'll start appending all those values into the matrix, into the string builder basically, right, from the matrix. So you can see that this is board I comma j. So this one will append each set values into the string builder, and then you will just return the sb.toString. So we are creating a hash for the current state of that board basically, right? Okay, so now you understood these two methods that we will use here in our DFS. So this is our recursive DFS method. So it takes a board as an input, it takes ij cell, right, and it takes number of steps, right? And first thing you wanted to do in the DFS is you wanted to check if this board is already now in reach the solved step, right? So you are checking if the board is in solved state now, right? So is solved board. If it reaches solved state, then you will create you will check if your current steps is smaller than your answer, then you will have to update your answer, because we are interested in finding minimum number of steps to reach to the target state. So that's what we are doing here, right? So we'll always keep track of the minimum number of steps required to reach to the target state here, right? After that, if it's not solved, then you will have to create the hash for your current board, right? So you create a hash here, and you will check your visited map, right? You have a visited map. So you will check if this hash code is existing there, right? So visited.get or default hash, if it exists and if it is less than the steps, right, then you will simply return. It means that you have reached the step, you have reached the state of that board previously with less number of steps. You understood, right? You have reached that state previously with less number of steps, then there is no point to go further, right? So you will return from this step, correct, from that point, because you already, it's kind of a, you already found out a minimum path, something similar, right? So you already found out a path with minimum number of steps already, so there is no point to go further, right? And here we have used get or default method. So if this hash is not there, then it will give you the infinity value, right? Correct. So let's say you uh, so if this is not true, then you wanted to mark that into your visited map, right? So you visited dot put hash code that you created for that board with number of steps that you have, right? So that we can keep track of the how many steps it took actually to reach to that board state, correct? Okay, so after that we are going to go in 4 directions, right? So here is the 4 directions. So x is equal to 0, x is less than 4, x plus plus. So these are the directions, right? So that we will calculate for new directions. So for example, so let me remove all this. So now you understood this. So now for example, if you are right now here, then this can be your new cell where you can go there basically, right, in 4 directions. So that's what we are doing here. So new I is equal to I plus directions x0, new j is equal to j plus directions x1. So you get the new coordinate of the cells, and you first wanted to make sure that these new cell coordinates are correct, right? They are valid, because if you want to go here, this is not correct, right? This is outside of the matrix. So you are checking it here. So new I is greater than equal to 0 and new I is less than equal to 1. New j is greater than equal to 0 and new j is less than equal to 2. Then only it's valid cell. If it is a valid cell, then we will simulate the swapping operation, right? We are now allowed to do the swap. So you will do the swap, right? So we'll first get the temporary value of that new cell in temp variable. We will update the board. New I new j is equal to board of ij, and board of ij is equal to temp. So we are actually doing the swapping, right? So for example, let's say you want to consider this cell and this cell, and you want to do the swapping. So you will put 4 here and you will put 0 here, right? So that is what that swapping does, correct? After that, you will recursively call DFS here, right? So you are recursively calling DFS, right? So recursive DFS here. Now when you are calling recursive DFS, you will pass board. Now this is important that you are passing new coordinates here, right? New I comma new j. And important thing, your steps is increased by 1 because you have done one more swap already, right? This one swap you have done, so you have to increment your step by 1, right? And after your DFS call comes back, you have to reset the swapped values, right? So you swap these values, right? So you have to reset it, put it back, basically make it like original, right? So reset the swap when coming out of DFS stack, right? So again you will do the swapping so that it will get reset. So temp is equal to board of ij, board of ij is equal to board of new I new j, and board of new I new j is equal to temp. So we have reset the swapping that we had done previously, right? So here so this is it actually as the implementation goes. So this is the place where we actually reach the salt state, and once we reach the salt state, then we want to keep track of the minimum number of steps it took us to reach there, right? So that steps we are capturing in answer variable, right? So here you will check. So now this is our main method, so you will check here. If the answer is equal to integer dot max value, it means that you never found out that answer. Basically you never be able to reach that target state. So if that is the case, you will directly return -1, otherwise you will return our answer that we found, right? So that's pretty much it as the code goes. So I explain you line by line everything. So now is the time to test this code and make sure it gives us correct answers. So for the first example, we are expecting 1 and we are getting 1, which is correct answer. For the second example, we are expecting -1 and we are getting -1, correct answer. For the third example, We are expecting 5 and we are getting 5, which is correct answer. Submit this code to the Leetcode. Make sure the code gets accepted by the Leetcode. And as you can see, the code is successfully accepted by the Leetcode. It is 5.32% faster on the performance side and almost 7% on the memory usage. So this is the way you can solve this hard problem on Leetcode 773 sliding puzzle. Another quite popular and hard coding interview problem on Leetcode. So I wanted to show you this logic, how we can use DFS to solve this problem and to make sure that we are not running out of the um, memory. We have used this visited map logic, and we have used that concept of creating hash so that we can avoid unnecessary calls, right? So I hope you like this Java solution code. You understood this logic, what I explained you with these examples, and you understood how we have implemented the DFS solution to solve this problem. So I'm going to add this Java code for you in my GitHub repository and give the link of my repository in the description section, where you will find lots of other programming and algorithmic solutions already implemented are available there for you. Those are important ones. You will find PL SQL, MySQL, Oracle, Java, J2E, Unix, JavaScript solutions are all listed out there in the GitHub repository for you. Those are the problems asked by big tech companies in their recent interviews. So make sure you go through them, understand them. They will give you more insight and ideas about how to do the implementations to solve different varieties of coding problems. And if you like those programming solutions in the GitHub repository, then consider giving it a star on the GitHub repository. That would be great. If you are new to this channel, there is a very important coding interview related playlist we have created to help your interview rounds. It is called as Leetcode and Leetcode Solutions. More than 200 most frequently asked very important coding interview problems are compiled for you under one playlist. Those problems are asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft many times in their past interviews. They are very important coding interview problems. Make sure you go through all of them, understand them completely. They will definitely give you a good preparation for your interview rounds, will help you learn more concepts of computer science and programming. If you want to practice more coding problems for your interviews, then there are 3 other playlists we have created on this channel for you. The names of those playlists are Code Forces, Code Chef, AdCoder. Lots of interesting, important and exciting problems are waiting for you there. If you like this today's solution, how we have solved this coding problem, sliding puzzle Leetcode 773 problem by using DFS and this logic, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Subscriptions are very important because that's how the videos can reach to other people, so others will also be able to watch and learn from this channel. So do subscribe it, share this content with all your friends and colleagues so they will also learn programming and problem solving. Click on the bell notification icon button right away so you'll always get immediate notifications for all our interesting solved coding problems videos from this channel. Here we create content to help others in their interview preparation process. If you are planning to take any Java interviews, then there are lots of Java J2E related videos we have created on this channel to help others. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables, they will ask you to write SQL queries. If you want to learn more data structures and algorithms, you want to know how to apply them to solve different computer science problems, and you also want to learn how to write and implement Java programs and solutions to solve those problems, then there are more than 400 different varieties of problems we have solved and demoed and explained on this channel for you. So go through them, they will definitely help you. All important coding questions varieties are covered here on this channel. That includes uh, dynamic programming, graphs, matrices, binary search trees, breadth first search, depth first search, cadence algorithm, binary search algorithm, Kruskal's algorithm, Dijkstra algorithm, sliding window algorithm. There are lots of other important data structure questions are also available on this channel for you. That includes stacks, queues, priority queues, hash table, hash map, reset, hash set, linked hash map, linked hash set, arrays, linked list. All are important problems. Those are selective coding questions. Those are asked by big tech companies many times in their past interviews. So make sure you go through them, understand them completely. They will definitely give you good preparation for your interview rounds. There is a small announcement for you here, that we are going to be bringing lots of fun and interesting fundamentals of databases, PL/SQL programming, and fundamentals of Unix programming videos for you here, that you can use to learn all fundamental and basic concepts of databases, such as how to create views, stored procedures, functions, triggers, how to use joins, how to use different aggregate functions to solve different PL/SQL coding problems. We will be showing you with real-time and practical examples with SQL database tables and SQL queries, so that you can understand how to solve SQL programming coding problems in interviews. We'll also show you important Unix commands and utilities and how to solve Unix problems in interviews. So make sure you stay tuned to this channel. Keep checking out the newly added videos here. Lots of fun and interesting videos are coming soon on this channel for you. If you like the videos from this channel, if they are helping your learning process, you are learning more coding, problem solving, programming, then please do leave your feedback and messages below these videos. Your feedback, your messages are very important for us. They increase our motivation to create more quality content videos on this channel to help others. So do leave your messages and feedback if you want us to create videos about any specific topics related to Java J2E programming. Then mention those topics in the below's comment section box so that we can create those videos for you here. If you haven't already checked out the playlist of this channel, go check out the playlist of this channel right away. You will definitely like those problems and you will also learn a lot from those problems. Lots of interesting problems are there, and the problems are categorized based on the problem types for your easier practicing purpose, so that you can easily choose a specific problem type category and you can practice those problems. So check out those playlists. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process and practicing going on continuously. And thanks for watching these videos.